Am I audible to you? 1 minute. See, we are discussing about the mutual exclusion procedure to be implemented in the distributed environment. Okay, so in the last class, we discussed about how the coordination and agreement will be done between the different communication nodes in the distributed environment. That is, the first sharing of the file system that is presented, that is remotely mounted on the different clients, and how it will be shared and requested among the different clients, and how it will be all things that could be coordinated and how they will be get agreed. That is, any group of the systems that are being included in the distributed environment, any group of systems that are included in the distributed environment are being agreed on certain rules and regulations and also policies, and they will be following certain rules and regulations in order to coordinate with each other and to communicate also. Okay. So in that case, so how the coordination and agreement will be done between. So collection of algorithms will be used to provide a communication in between the peer-to-peer process, right? And in that particular coordination process, so what happens will be things, a set of processes are going to be agreed on a one or more rules, and there will not be any master-slave relationship in between them. And a failure model is going to be followed in order to trace any problems in the connected systems of the connected network of the systems which are following on a certain group of rules and regulations. Okay. And the what is called as whenever there is a collection of systems which are going to communicate with each other, obviously we have to make them to be communicated internally with each other, and also to make that data to be shared promptly. Data to be shared promptly, replicas has to be maintained at different clients. Okay, so by providing a lot many different copies of the data on the different positions instead of a single system point, you are going to maintain the replicas. Okay, so these are all the rules that are going to followed by the coordination and agreement process, agreement thing when pertains to distributed environment while sharing the data. So the file distributed file system is going to be shared between the systems of the distributed environment based upon a coordination and agreement policy. So what is the policy is there will be relied up to certain particular rules, and there will not be any master slave relationship among the systems, and a particular failure model will be followed by the systems in order to trace out the data and any failure of the process of the system included in the corresponding environment. And group communication will be leading to certain problems and all those things. By using the message passing paradigm itself, we are going to make the group communication to be reliable. Okay, a multicasting process will be used in order to send the data to the multiple parties, and at the same time replicas will be maintained at different groups. Okay, and while following the failure model, what you are going to do is we will have certain failure assumptions that there may be chance of retransmitting the data whenever there is a missing of the data from the receiving party. In that case, how the data will be get sent through, how you are going to what is called as assuming and prospering that corresponding failure has been issued here because of the data that has been missed in the communication channel or availability of data to receive by the corresponding receiver. All these are to be the failure assumptions. And next one is whenever there will be a network partition, that is it doesn't know that whether the router or bridge has been got broke up, or it has been misbehaving, or how it is going to be not what is called as properly communicating with all the parts of the network. Then it is called as a network partition. So these could be the failure assumptions. Either one is the corresponding communicating the data. That is how you are going to retransmit the messages, how the retransmission of the messages is going to be problem creating or what. Next one is how the network partition is going to be a failure problem. This could be the failure assumptions in a distributed environment. How do we have to detect these failures? A failure detector is a service that a process, whether a particular process is failed or not. Okay, it's going to be decided by the failure detector. And this particular failure detector is going to be implemented on a specific computer by running an algorithm to identify that whether the system is able to communicate or whether the system is properly communicating or not. And that particular failure detector is called as the local failure detector. And local failure detectors have the two categories: unreliable failure detector and the reliable failure detectors. Unreliable failure detectors are going to be depending upon two characteristics: unsuspected and the suspected. If the result of the unreliable failure detector is unsuspected, it is unambiguous. It's not going to be intimating you any perfect failure. That is, it is going to be intimating you that there may be a chance of failure. It may have. Recently, I got the message from that particular process, so that it couldn't be a problem with that particular process. It's going to be intimating in that way, unsuspected. It's not going to be suspecting any problem at any cost. So in that way, we couldn't identify whether the problem with the process or anything. Okay, and next one is expected, suspected. Okay, so unexpected signifies that there is no problem at all. And suspected is going to be revealing you every time that it's a problem with the system itself. I didn't receive the message recently from that particular process, so that it may got failed. He doesn't know that whether the process has been failed naturally or not. But we are going to be posing that you are going to be every time suspecting, or you are not going to be not at all suspecting. These are all the cases with the unreliable failure detectors. And coming to the reliable failure detectors, they are going to be giving the proper information promptly whenever there is a problem with the corresponding process of the system presenting in the network. Okay, and that is about the failure model that is going to be followed by the coordination agreement process to one of the rules that is to be followed in the coordination agreement, and to interleave with the data whenever the processes are going to be sharing the common resources. Automatically, visual execution is required in order to interleave them in sharing the data. Okay, that already you know about what is a visual execution, how will be implemented in the operating system, how it could be achieved, what are all the different processes that will be followed in order to maintain the consistency among the shared data. Okay, and the data that is going to be included in the mutual execution procedure will be called as the critical section. And in this particular distributed environment, the mutual execution will be implemented by using a process called as message passing. By using a message passing, that is among the process that you are going to have with the mutual execution. In the mutual exclusion procedure, message passing is one of the procedure or the solution that we learn in the operating system. And that particular message passing will be followed by the distributed environment in implementing the mutual exclusion. Okay. And algorithm for mutual exclusion, already you know that there will be a critical section. Somebody will be entering into the critical section in order to execute. And after completing the work, it will be exiting from the critical section, allowing the other process to enter into it. That is the actual and general procedure that we know. And according to the distributed environment, here this entering into the critical section and exiting the critical section has been divided into two main rules, ME1 and the main ME1. That is mutual exclusion 1 and mutual exclusion 2. Mutual exclusion 1 is being identified as the safety rule, and ME2, that is the mutual exclusion 2, has been named as the liveness rule. So what about the safety rule is, at most one process may execute and enter into the mutual exclusion at once. At most one process enters into the mutual exclusion and executes. Next one is liveness. Request to enter and exit the critical section even successfully. That is, it's going to be trying to enter into the mutual exclusion, critical section, but at a live context, that is without getting blocked or without getting stabbed or without getting deadlocked. It's going to be requesting the process or the critical section to enter into itself and execute it, and it is sharing the resources of that particular critical section and exiting from that particular critical section safely or properly without blocking. Okay, without getting blocking, we'll be doing our data, we'll be doing our work. And next one is, at least one process is going to be entering into the critical section. We doesn't care about other process. At least one process enters into the critical section. That is the safety. Next one is live messages you are going to be entering, even though you are going to enter into the critical section or not, even when we been enter into the critical section, we have to be live. We have to be in a live position without getting blocked. Okay, you are not going to be suspended. You are not going to be blocked. Okay. And coming to the performance of the mutual exclusion algorithm, the performance of the mutual exclusion algorithm is being measured with the different characteristics like bandwidth, throughput, synchronization delay. Okay, bandwidth depending upon the number of messages entered and exit of the operations, and client delay is incurred by the process at each operation. Throughput of the system is nothing but that how many number of processes has been successfully entered into the corresponding critical section and exited. Okay, so these are all the three features which are going to be, sorry, four features which are going to measuring the performance of the mutual exclusion algorithms. Okay. Mm. So coming to the other mutual exchange algorithms that have been implemented, there is the first one is the central server algorithm that is already we discussed. In the central server algorithm, we will be having a central system which is going to be passing or it's going to be taking control of or coordination of who is going to be entering into the critical section, who is going to be exiting. They has to, that is the all the clients has to request the particular central server algorithm to get the permission to enter into the critical section. That is going to be granting you tokens to enter into it or exiting of the critical section that we already saw. So this is the central server algorithm implementation that we depicted here. One is going to be requesting the token and another is going to be releasing the token and it's going to be granted with the token to enter into the critical section. And the server system is going to maintaining the queue of all the processes that are requesting for entering into the critical section and issuing them different tokens by itself and making all the other processes to be in the queue one after the other to enter into the critical section and exiting it. Okay. And here depending upon the number of messages included in like requesting the token to enter into the critical section and exiting out of it or releasing that particular token to exit out of the critical section and granting the token to the particular process to enter into the critical section. All these concerns with the bandwidth and also throughput is going to be yielding, including this round trip complete round trip of a complete cycle. That is right from beginning of the request of the token and they are waited in the queue and getting the response and you will be getting access of the corresponding critical section and exiting out of the critical section by releasing the token. All these things refers with the, okay, this is how the central server algorithm is going to be working. And coming to the ring-based algorithm, this ring-based algorithm, no particular server will be there which is going to controlling all the tokens are, I mean, all the processes are going to be passing the tokens, identifying that whether they could be trying to exit, I mean, enter into the critical section or they want to try exit out of the critical section. So that one process is going to be passing the message that whether it wants to enter into the critical section or not. If it wants to enter into the critical section, it will not pass the token to the corresponding neighboring or the forwarding the token to the other process. So that obviously it will be entering into the critical section. After exiting out of the critical section itself, the token will be passed to the some other neighboring process. Then only the process can take that particular token and will enter into the corresponding critical section. It doesn't want to enter into the critical section. It simply passes the token to the remaining neighbors or the adjacent neighbor itself. That is how the ring-based algorithm is going to be working. And you also saw that how the Ricardo and Agrawal algorithm is going to be working. In this particular Ricardo and Agrawal algorithm, the entering of the, I mean, so sorry, the critical section state will be made, critical section region will be maintained with three states: released, wanted, and now held. So if it has been free or it's in a idle position, it will be in the releasing state. Otherwise, if it has been requested by any particular process, it will be in the wanted state. And if it has been already processing by a particular process, then it will be in the held state. It will be depending upon the logical clock. So depending upon the timestamp, here we are going to deciding that whether the process has to enter into the corresponding critical section or not, whether the time of that particular timestamp of that particular process is higher or lower. The lower the timestamp, the corresponding job is being response granted to enter into the critical section. Okay, so here the multicast, that is the all the processes are going to be which are willing to enter into the critical section has to multicast or broadcast the timestamps to all the processes in the network. So which group that they are being existing and through which group they are being communicating, for all the particular group members, they has to broadcast their timestamp before they want to enter into the critical section. So whenever every other process replies it back, it assumes that its timestamp is less so that it has been had got the grant of enter into the critical section. Otherwise, even though one of the process among the group has been not replied, then it assumes that it is not having the chance of entering into the critical section. The other one which has not been replied to itself has been got the lower timestamp and it has the chance of entering into the critical section that we already discussed in the last class here. P1, P2, P3 processes are being trying to enter into the, they are being presenting in the communication, whereas P1 and P2 are trying to enter into the critical section. In that case, P1 is having the what is called timestamp of 41 and P2 is having the timestamp of 34. So all these two are going to be communicating their timestamps to with each other and also to the another process present in the group with the P3. Okay, so P3 is going to be replying. P3 is going to be replying both to both the process. Why? Because it doesn't want to enter into the critical section. It doesn't bother about whether it is having the lower timestamp or other processes having the lower timestamp. So the simply it's been replying to both the processes P1 and P2. And P1 is also being replying to the P2 as P1 is having the higher timestamp when compared to the P2. So P2 doesn't will be back acknowledging the P1 as P2 itself is having the lower timestamp when compared to the P1. So the P1 will be blocked to not enter into the critical section, whereas P2 will be now having the chance to enter into the critical section. That is about the Ricard and Agarwal. And another one is Markow's voting algorithm. This algorithm, what happens is not all anytime one process is being allowed to enter into the critical section. So how it will be done is by the process of the voting. So that we'll be dividing the total groups of total number of processes into number of groups. From that particular groups, any process may want to enter into the critical section. So that all the set of processes are going to be trying to vote to that particular requested client. If all the other set of processes are been referring with the same client or no client has been or no resource is going to be what is called as clashed by any set of processes. No resource request is being clashed by any set of resources. Then the one which has been requesting that particular process will be the particular resource will be get granted. That is based upon the voting majority, the corresponding process will be get allocated to enter into the critical section. That is about the MACOS certain algorithm. That is what we already discussed in the last class. Now we have to discuss about the fault tolerance or the things that has been happened. What happens if one of the gets failure in all the cases? So while implementing the mutual exclusion in the distributed environment, if in all the cases, if any one of the process has been got failed or it has been got some problem or it has been crashed somewhere, so what happens? Whether the systems, whether all the algorithms could be able to tolerate that particular failure in that moment or not. Whether all the algorithms are able to tolerate that particular failure in all the procedures or the implementation. See, we'll see here what happens when a messages are lost. ఒకవేళ మెసేజ్ పోయినా లేదా ప్రాసెస్ క్రాష్ అయినా మన అల్గారిథమ్స్ వెయిట్ ఎంతవరకు ఫాల్ట్ ఆ పర్టికులర్ ప్రాబ్లమ్ ని అవి బేర్ చేయగలవు. ద ఫస్ట్ వన్ ఇస్ the ring-based algorithm cannot tolerate any single process crash algorithm. So ring process law, obviously one message has to be transferred with the another. The token has to be passed on to the next process until and unless the token will be passed to the neighboring process. The process will not start the corresponding what is called as trying to enter into the critical section. So that if the token passing process has been crashed because of some reason, the token will not be released by that particular process forever. All the other tokens will be all the other processes will be get blocked. That is the problem with the ring based. So ring based algorithm లో దేని దగ్గర అయితే టోకెన్ ఉందో ఆ టోకెన్ అది పాస్ చేయకుండా ఆ సిస్టమ్ క్రాష్ అయింది అనుకోండి, ఆబ్వియస్లీ మిగతా సిస్టమ్స్ వేటికి కూడా వాటికి టోకెన్ రిసీవ్ అవ్వదు. ఆబ్వియస్లీ సిస్టమ్ అంతా కూడా స్ట్రక్ అవుతుంది. నెక్స్ట్ వన్ ఇస్ మెకావా. మెకావా ఓటింగ్ చూసుకుంటే it can tolerate some process crash failures. If a crashed if a crasher process is not in a voting set that is required. ఒకవేళ కనుక మనకి ఆ, తీసుకున్న సెట్ ఆఫ్ ప్రాసెసర్ లో కనుక ఏ సిస్టమ్ అయితే మనం ఓట్ చేసుకుంటున్నామో క్రాష్ సిస్టమ్ కనుక ఆ లిస్ట్ లో లేకపోతే దెన్ we will be tolerating. That is, then the Maca's algorithm can be able to tolerate if the set of systems is not being consisting of the crasher systems, okay, which are trying to vote. Okay. Next one is central server error. ఎందుకంటే సెటప్ ప్రాసెస్ ఏమైతే మనకి ఓట్ చేయాలో ఒక పర్టికులర్ what is called as ఒక సిస్టమ్ ని ఎలెక్ట్ చేయాలో if one of the process has been got crashed, obviously we not having the vote from that particular system, we will be blocking that particular thing. Okay. Next one is central server algorithm. Automatica is going to be tolerating another one of if that neither holds has a main token. టోకెన్ ఎవరి దగ్గర లేకపోతేనే తప్ప సెంట్రల్ సర్వర్ అల్గోరిథం లో ఒకవేళ సెంట్రల్ సిస్టమ్ కనుక క్రాష్ అయితే దెన్ ఆబ్వియస్లీ we'll be having the problem with all the systems which are being connected to that particular central server. Okay. So that is the thing. Next one is Ricata and Agarwala. So in this particular one, we will be identifying the timestamp. So according to the timestamp itself, we will be easily and fairly, we are going to be and making all the process to enter into the critical section. So that is the benefit of the Ricata and algorithm. Okay. That is about the fault tolerance. So coming to the elections. So what is the elections is nothing but here, whenever we are trying to make them or give some role to the one of the systems presenting in the distributed environment. So distributed environment, group of process ఏవైతే ఒక particular rules and regulations మీద depend అయి ఉన్నాయో ఆ particular group లో ఏదైనా ఒక particular system కి if you want to give some role, okay, then particular algorithms which will be used to elect that particular process which is has to given with certain role are called as elections. ఒక గ్రూప్ ఆఫ్ సిస్టమ్స్ లో ఒక సిస్టమ్ ని మనం ఒక పర్టికులర్ రోల్ కి చూస్ చేసుకోవాలి అనుకుంటే వీ హ్యావ్ టు యూజ్ దిస్ ఎలక్షన్స్. ఓకే. అండ్ ఫర్ ఎగ్జాంపుల్ ఫీచర్ ఎక్స్క్యూషన్ అల్గోరిథమ్స్ తీసుకున్నాం, అందులో మనకి సెంట్రల్ సర్వర్ అల్గోరిథం ఇంప్లిమెంటేషన్ తీసుకుంటే ఎనీ వన్ సిస్టమ్ హ్యాస్ టు యాక్ట్ as the central server. So how the particular central server will be elected. Okay, every other system in the network, every other system in the set has to agree that particular the system which has been to be acting as a server has to be agreed on. So అన్ని systems కలిపి ఒక system agreement ఒక agreement వచ్చి okay we are going to be we are been accepting that the system can act as server అని ఒప్పుకుంటేనే that particular system will be acting as a central server. Okay. So how it could be done, ఎలాగ మనం అది చేస్తూ ఉంటాము, how the election will be performed, not only just interleaving the processes to enter into the critical section and making them to be exit out of it, we have to also choose one of the process to be act as a particular role playing అన్నమాట. So how the particular elections has to be done అంటే ఇక్కడ కూడా two requirements ఉన్నాయి. ఒకటి safety and liveness. ఏంటి అంటే in the safety thing, a participant process has to be elected as a particular role, elected for a particular role. ఒక పర్టికులర్ పార్టిసిపెంట్ ప్రాసెస్ ఏదైతే ఉందో లేదంటే క్లయింట్ ఏదైతే ఉందో దాన్ని మనము ఒక రోల్ రోల్ ప్లేయర్ గా ఎలక్ట్ చేసేయటం. ఓకే. అండ్ అనదర్ వన్ ఇస్ ఆల్ ప్రాసెసెస్ పిఏ పార్టిసిపేట్ ఇన్ ఎలక్షన్ ప్రాసెస్ అండ్ ఎవెన్చువల్లీ గెట్ సెలెక్టెడ్. ఒకటి ఒక దాన్ని మనం పర్ఫెక్ట్ గా మనకు మనమే గ్రాంట్ చేసేసి ఇచ్చేసేది లేదు. ఉన్న ఆల్ అదర్ what are the process presenting in a group will be participating in the election process and will be get elected eventually by all those things. సో ఒకటి మనం డైరెక్ట్ గా ఒక దాన్ని ఎలక్ట్ చేసుకోవటము, సెలెక్ట్ చేసుకుని దాన్ని సర్వర్ గా యూజ్ చేసుకోవటము ఒకటి సేఫ్టీ ప్రాసెస్. నెక్స్ట్ లైవ్నెస్ ఏంటి అంటే వీఆర్ నాట్ గోయింగ్ టు బి పార్షియలీ గివింగ్ అ పర్టికులర్ ఛాన్స్ టు ఎనీ వన్ ప్రాసెస్, విల్ బి ఏబుల్ టు నో ద అదర్స్ probability by electing one of the system to be the server. They will be choosing themselves as one of them as the particular role player. ఒక పర్టికులర్ రోల్ ప్లేయర్ గా వాళ్ళ గ్రూప్ లో వాళ్ళే సెలెక్ట్ చేసుకోవడం అంటే యూజ్ అమాంగ్ ద సెట్ ఆఫ్ ద ప్రాసెసెస్ దే విల్ బి themselves electing one of the process to be as a particular role player. These are the two requirements in the elections algorithm. And within that, we'll be having the ring-based algorithm. So within this, already you know about this ring-based algorithm, ring-based election or the ring-based procedure, how that will be done. Here also the same token will be used to pass it from one to the another, whereas identifier will be passed to this particular token in this elections ring-based algorithm. uh, ring-based election algorithm. So what's the token consisting of? It is consisting of an identifier. So whenever an identifier which has been passed from one system to the another system, the token which is having the highest identifier will be elected as the corresponding రోల్ ప్లేయర్. ఏ రోల్ ప్లేయర్ గురించి అయితే మనం ఎలక్షన్స్ పెట్టామో ఆ పర్టికులర్ సిస్టమ్ కి దేనికైతే లార్జెస్ట్ ఐడెంటిఫైయర్ ఉందో దానికి అది యాక్చువల్లీ విల్ బి ఎలక్టెడ్ యాజ్ ద కరెస్పాండింగ్ రోల్ ప్లేయర్ అనమాట. ఎలాగో తెలుస్తుంది మనకి సో అండ్ సో సిస్టమ్ హ్యాస్ హ్యావింగ్ ద ఐడెంటి ఐ మీన్ లార్జెస్ట్ ఐడెంటిఫైయర్ అంటే a token will be passed from a token consisting of an identifier will be passing from one system to the another system in the ring. If any token will be comparing its identifier with the corresponding token identifier, if it identifies that its id is being different from our identity is smaller with the received identifier, then it will be remaining calm and it will be passing over that particular thing. Okay. And if it is saying that it's having its own identifier larger when compared to the received token, then it won't pass the token. ఓకేనండి. సో ఎప్పుడైతే మనకి ఒక వాట్ ఇస్ కాల్డ్ యాజ్ ఫేషియల్ ఎక్స్ప్రెషన్ లోకి మనం ఎంటర్ అవ్వాలనుకుంటే టోకెన్ ఎలాగా పాస్ చేయము, ఎప్పుడైతే మన దగ్గర ఉన్న ఐడెంటిఫైయర్ వాల్యూ ఎక్కువ ఉందో when the received token when compared to the received token, then we are not going to be passing the token to the other thing, and we are going to be advertising or exhibiting ourselves as the elected member, or we are going to be acting as a coordinator from there onwards to the total systems presenting in the ring anamata. That is how a ring based algorithm will be working on. That is what they are being saying at మన ఐడి పెట్టుకుని మనం అప్పటిదాకా కోఆర్డినేటర్ అని చెప్పేసి మనం అనౌన్స్ చేసుకుంటాం whenever we are having the largest identifier when compared to the identifier presenting in the token that we received from the other system in the ring. Okay, that is what these are all the steps that I have been discussed. ఇవన్నీ నేను చెప్పిన స్టెప్స్ అది రింగ్ బేస్డ్ ఎలక్షన్ అల్గోరిథం లో జరుగుతుంది. ఓకే, బల్లి అల్గోరిథం. సో ఇప్పుడు ఈ బల్లి అల్గోరిథం లో ఏం చేస్తుంది అంటే all process to crash during an election, all the assumes that messages between processes are reliable. సో ఒకళ్ళకొకళ్ళు సిస్టమ్ నుంచి సిస్టమ్ కి పాస్ చేసుకున్న ఎలక్షన్ లో ప్రాసెస్ క్రాష్ అవ్వడానికి ఛాన్సెస్ ఉన్నాయి. ఎందుకు అంటే ఇఫ్ దే డజంట్ హ్యావ్ ఐడెంటిఫైయర్ ఫర్ ఎవర్, వాటి దగ్గర ఉన్నది ఎప్పుడు ఐడెంటిఫైయర్ చాలా ఎప్పటికీ అయినా సరే దే ఆర్ నాట్ బీన్ రిసీవింగ్ ద ఐడెంటిఫైర్ దట్ ఇస్ లెసర్ దాన్ దేర్ ఐడెంటిఫైర్ ఆర్ హైయర్ దాన్ దర్ ఐడెంటిఫైర్. వాళ్ళ దగ్గర ఉన్న దానికన్నా కూడా ఎప్పుడు హైయర్ ఐడెంటిఫైర్ రిసీవ్ అవుతుంది అనుకోండి, ఆబ్వియస్లీ దే వోంట్ గెట్ ద ఛాన్స్ టు బి యాక్టింగ్ యాజ్ అ కోఆర్డినేటర్. ఓకే, సో దట్ ఆటోమేటికల్లీ ఒకవేళ సిస్టమ్ సిక్వెన్స్ అనుకోండి, టైమ్ అవుట్స్ ఆర్ గోయింగ్ టు బి డిటెక్టింగ్ ద ప్రాసెస్ ఫెయిల్యూర్. ఆటోమేటిక్ గా టైమ్ అవుట్ అయిపోయిన తర్వాత ఇఫ్ యు ఆర్ నాట్ గెటింగ్ అవర్ ఛాన్స్ టు యాక్ట్ యాజ్ అ కోఆర్డినేటర్, ఇఫ్ ద time has been out of to act as a coordinator in the ring, obviously you will be detected as the process failure. That is, your system is not been working. You are not going to communicating anything to the outside environment, so that you got failed any assumption వస్తుంది. So that అక్కడ ఏం చేయాలి, or how you have to thing is what you have to do is each process know which process have identifiers. మనం ఇక్కడ ఏం చేస్తామంటే ఏ ప్రాసెస్ కి హైయర్ ఐడెంటిఫైయర్స్ ఉన్నాయో మనం కమ్యూనికేట్ చేసుకుని డిసైడ్ చేసుకుంటాం. సో ఎలా చేస్తాము, హౌ యు ఆర్ గోయింగ్ టు కమ్యూనికేటింగ్ అంటే త్రీ మెసేజెస్ ఆర్ విల్ హెల్ప్ఫుల్ ఫర్ us in order to identify which system is having the largest identifier, which system is having the largest identifier అని మనకు తెలియాలి అని అంటే three messages will be used. So what are those is election message is sent to announce an election message. A process begins an election when notices through timeouts that the coordinator has failed. Okay, so how the timeouts will be identified is t is equal to 2 transpose plus t process from the time of sending. So after sending the election message, whenever the time has been got out, election message has been time got out, then it's going to be uh, failed. The coordinator is going to be failed. Otherwise, if it's being got received by somebody, then it will be got elected. Answer is sent in response to an election message. Every process which has got the election message has to send with the answer. Whether your transmission time and process time will be equal to the time that has been sent by the corresponding election message. If that particular time is equal to your transmission time and the process time, then you will be elected as a coordinator. So if coordinator is sent to announce the identified of the electoral process. So ఎప్పుడైతే మనకు పర్టికులర్ ప్రాసెస్ మనం ఐడెంటిఫై చేస్తామో this process is having the highest identifier and also the highest timeout, then that will be announced as the coordinator and will be sent to all the other processes in the communication group. That is the Belly algorithm. That is, we are intentionally making them. You are going to doing, you are going to identify whether you are having the largest time or not. So if it is been identified that you will be having the highest time, then you will be declared anamata. So other will be kicked off. They are not going to be allowed to participate in the election, whether if they are having the lowest time. Okay, this is how what they have been given or explained. Okay, so they will be communicating. Election message will be given, answer will be compared. After getting the answer, we'll be transmitting whether we got the data or not, who is going to be done. So eventually everything will be participating and nobody are going to be allowed. They are not getting the response. So P3, P4 are avoided. However, whereas P1 and P2 is being communicating, well, P1, P2 is communicating, they have been identified that the P2 will be acting as a coordinator, but identified that P2 is having the highest timeout value. Okay, so that is what. So coming to the another section, so that is how the sorry, what is called as election algorithms will be implemented and the mutual exclusion algorithms will be implemented. Okay, one moment. So coming to the multicast communication. So how the multicast communication will be done, how it has to be implemented, how it is going to be provided in the distributed environment, how we are going to broadcasting our data from one system to the another system or many number of systems. So multicast operation is nothing but sending a single message from one system to the a set of members of the group of process. Okay. So in this way, the membership of a group is transparent to the sender. Okay, membership of a group is transparent to the sender. That we know that where we are being sending, who is being receiving, and also receiver is going to be able to know that from where the data is being getting from. Okay, who is being sending, whether the single person is been sending the data to us or we are getting the data from the multiple parties, all those things. Okay. So multicast, based upon the multicasting procedure itself, we are being able to get the standard quality of the distributed system. So distributed systems యొక్క క్వాలిటీస్ క్యారెక్టరిస్టిక్స్ స్టాండర్డ్ గా మనకి రిసీవ్ అవ్వాలి అని అంటే మల్టీకాస్టింగ్ ఎంత ప్రాపర్ గా మనం చేస్తున్నాం అనేది దాని మీద ఉంటుంది. సో దట్ మల్టీకాస్ట్ మెసేజెస్ ఆర్ బీన్ ప్రొవైడింగ్ ద యూజఫుల్ థింగ్స్ దట్ హ్యాస్ టు బి యూస్డ్ ఫర్ కన్స్ట్రక్టింగ్ ద డిస్ట్రిబ్యూటెడ్ సిస్టమ్ ఎన్వైరన్మెంట్ అనమాట. ఏంటి అంటే fault tolerance based on replicated services. Okay, అంటే ఏంటంటే if any system has been got failed or if any there is a problem in the communication channel, if you are got losing the messages in between the transmission, so how you are going to getting the data back because of the data that has been replicated somewhere, even though the destination system which has been got failed, which has to send your data, then you are able to get the data from some other point where your data has been replicated there. So the original system has been crashed, but the replicated data somewhere at some point in the group will be able to send you some data. So that is one thing. Fault tolerance based on the replicated services. Okay. So replicated service consists of a group of service. Clients request and multicast to all the members. అందరికీ కూడా మనం డేటా పంపిస్తాము, అందరూ కూడా రెడీగా డేటాని ఇవ్వడానికి ఉంటారు. అంటే అందరూ పంపించేస్తారని కాదు, బట్ హూ ఆర్ ఏబుల్ టు రిక్వెస్టెడ్, who are being destined with a particular address, they will be giving the data. Next one is discovering services in spontaneous networks. Discovering services in spontaneous networks. So in the only network where you are been searching for is not only being able to address the request that you have been given, but whoever may be the network which are being spontaneous, which are being not there. ఎక్కడ ఏ పర్టికులర్ నెట్వర్క్ లో అయితే మనకి డేటా ఉందో దాన్ని మనం లొకేట్ చేసుకుని యూ కెన్ ఐడెంటిఫై, యూ కెన్ గెట్ దట్ పర్టికులర్ డేటా, ఆల్ దీస్ థింగ్స్. మనం అక్కడ నుంచి డేటాను మనం తెచ్చుకోవడానికి తీసుకోవడానికి కూడా మనకు అవకాశం ఉంటుంది అనమాట. స్పాంటేనియస్ నెట్వర్క్స్ అంటే ఈ పర్టికులర్ నెట్వర్క్ నుంచే కాదు, వేర్ ఎవర్ హూ వాట్ ఎవర్ ద నెట్వర్క్స్ processing the data, they will be seen to be enabled. మనకు అవి ఎనేబుల్ అయి కనిపిస్తే అక్కడి నుంచి మనం డేటాని తెచ్చుకోవచ్చు. ఓకే, అండ్ బెటర్ పెర్ఫార్మెన్స్ త్రూ రెప్లికేటెడ్ డేటా, దిస్ ఇస్ ఆల్సో బీ డన్. ఒకటి ఫాల్ట్ టాలరెన్స్ కెన్ బి అబ్టైన్డ్, అండ్ నెక్స్ట్ వన్ ఇస్ డిస్కవరింగ్ ద స్పాంటేనియస్ నెట్వర్క్స్, అండ్ థర్డ్ వన్ ఇస్ better performance through replicated data. Obviously, whenever there is a replicated data, best performance will be yielded. Best performance results with multiple number of clients can access the data from the multiple replica positions without any conflict and without rushing onto the communication channel, or what is called placing much of burden on the server. సర్వర్ మీద బర్డెన్ ఒకటే చోట పడడం కానీ, లేకపోతే ఒక పర్టికులర్ పర్సన్ యాక్సెస్ చేసుకుంటే ఇంకొకరికి యాక్సెస్ చేయకపోవడం కానీ, లేదంటే కమ్యూనికేషన్ ఛానల్ మనము రష్ అప్ చేయడం కానీ లేకుండా బెటర్ పెర్ఫార్మెన్స్ చాలా ఈజీ వేలో విత్ అ సింపుల్ వే we can access the data from the replica points from the multiple parties. And next one is propagation of event notification. Obviously, because of the multicasting, we will be get notified from the multiple parties with the specific news and notifications. For example, మన మొబైల్ తీసుకున్నాం అనుకోండి, వీఆర్ లాంచింగ్ విత్ ఆర్ వీఆర్ ఓపెనింగ్ విత్ మల్టిపుల్ అప్లికేషన్స్, నెంబర్ ఆఫ్ అప్లికేషన్స్ మనము ఓపెన్ చేసి పెట్టుకుంటాం, అండ్ వీఆర్ హ్యావింగ్ ద ఛాన్స్ టు ఎనేబుల్ ద నోటిఫికేషన్స్ ఫ్రమ్ దట్ పర్టికులర్ యాప్. సో ఆల్ దోస్ యాప్స్ ఆర్ గోయింగ్ టు బోయింగ్ నోటిఫైయర్స్. సో అంటే ఒక పర్టికులర్ డివైస్ కి మల్టిపుల్ యాక్సెసింగ్ పాయింట్స్ నుంచి వేరే వేరే అప్లికేషన్స్ నుంచి వీఆర్ గెటింగ్ ద నోటిఫికేషన్స్ టు ద సింగిల్ పాయింట్. వెదర్ we will be the single user, మనకి మాత్రమే ఆ నోటిఫికేషన్స్ వస్తాయా? No, whoever will using that particular apps, all are getting their notifications. For example, Facebook తీసుకుంటున్నాం, and if you are been using the data, some friend has been posted something on our wall, we are getting the notification. Whether you are only getting the notification of your Facebook, know that whoever be having the access of the Facebook, and who of your friends are being there, they will be getting the notifications whatever you have shared on your timeline. మీ టైంలో మీరు ఏం షేర్ చేసుకున్నారో, if you are giving the chance to view that particular sharing, obviously all the friends of your friends can also view the data. So in that way, propagation of the event notifications will be easily done for set of people in chain and matter. So these are all the characteristics which will be used for constructing the distributed system through the multicasting. Multicasting use చేసుకుని మన fault tolerance achieve చేయొచ్చు, సర్వీసెస్ మనం స్పాంటేనియస్ గా ఫైండ్ అవుట్ చేయొచ్చు, బెటర్ పర్ఫార్మెన్స్ అచీవ్ చేయొచ్చు, అలాగే ఈవెంట్ నోటిఫికేషన్స్ కూడా ఈజీగా మనము పర్ఫామ్ చేయొచ్చు. అలాగే మల్టీకాస్ట్ కమ్యూనికేషన్. సో మల్టీకాస్ట్ కమ్యూనికేషన్ ఎలా సో ఈ మల్టీకాస్ట్ ఐపీ మల్టీకాస్ట్ లకు మనం ఎలా కమ్యూనికేట్ చేస్తాం అంటే, దిస్ మల్టీకాస్టింగ్ ఆపరేషన్, మల్టీకాస్ట్ కమ్యూనికేషన్ హౌ ఇట్ ఇస్ ఇంప్లిమెంటెడ్ ఇన్ ద ఐపీ ఎలా చూస్తాము అంటే, సో గ్రూప్ కమ్యూనికేషన్ వచ్చేటప్పటికి మనకి నెంబర్ ఆఫ్ గ్రూప్ కమ్యూనికేషన్ ప్రోటోకాల్స్ ఉన్నాయి, అండ్ దట్ ఐపీ మల్టీకాస్ట్ విల్ బి ప్రొవైడెడ్ విత్ మల్టీకాస్ట్ సాకెట్ క్లాస్. సో అక్కడ మనకి మల్టీకాస్టింగ్ ఎలా కుదురుతుంది ఐపీలో అని అంటే, ఐపీ ఈస్ గోయింగ్ టు బి ఇంప్లిమెంటింగ్ ద మల్టీకాస్ట్ సాకెట్ క్లాస్, multicast socket class. Because of this particular multicast socket class, which is going to be using the IP protocol, is on the top of the IP protocol stack. ఎందుకు అంటే, ఇట్స్ గోయింగ్ టు బి బిలాంగింగ్ టు బోత్ ద టీసీపీ అండ్ ద యూడిపి లెవెల్స్. ఇట్స్ గోయింగ్ టు బిలాంగ్ టు ద టీసీపీ యూడిపి లెవెల్స్. అంటే ఒక పర్టికులర్ సెట్ ఆఫ్ కమ్యూనికేషన్ డివైజెస్ కి మనం పంపించాలి, లేకపోతే వాళ్ళతోనే మనం కమ్యూనికేట్ చేయాలని ఏం కాదు. We can also communicate with the TCP level of data systems and also the UDP level of the communication protocols. So both the devices which can be accessing with that UDP protocols or also the TCP protocols can be able to communicate with the IP multicast socket classes. Using that particular thing, we are going to sending the data to both the type of the devices. Sender doesn't able to know that whether he has been receiving the data from the a UDP level type of device or the TCP type of device, whether they are following the IP protocols and all those things. అసలు ప్రోటోకాల్స్ ఏం యూజ్ చేస్తున్నారు, టీసీపీ యూజ్ చేస్తున్నారా, యూడిపి టైప్ ఆఫ్ కమ్యూనికేషన్ యూజ్ చేస్తున్నారా, ఏ టైప్ ఆఫ్ స్టాక్ కమ్యూనికేషన్ యూజ్ చేస్తున్నారు అనేది తెలియదు. సో దట్స్ వాట్ ద స్పెషాలిటీ ఆఫ్ ద ఐపీ మల్టీకాస్ట్ సాకెట్ ఇంప్లిమెంటేషన్. దట్ ఈస్ మల్టీకాస్ట్ కమ్యూనికేషన్ మనకి ఎలా కుదురుతుందండి, ప్రాక్టికల్ గా మనం ఎక్కడ చూడగలము, వేర్ వీ కెన్ సీ దట్ అంటే, ద సాకెట్ క్లాస్ విచ్ యూ ఆర్ గోయింగ్ టు యూజ్ ఇన్ ద ఐపీ implementation, where you can identify in the socket classes or socket importing class. In that you can find the multicast socket class implementation, which is used to communicate with both the type of the devices. Okay. So that ikkada multicast meters ఉంటాయి, multicast address allocation ఉంటుంది. Already you know about this. I think no need to explain here what are all the classes of the networks that you are having, IP addresses, how they will be get divided. లో LAN కి అయితే ఎలా మనం డివైడ్ చేస్తాము, WAN కి అయితే ఎలా డివైడ్ చేస్తాము, how the casting addresses will be identified, how the sockets will be belonging to that particular group, how the deviation of the IP addresses will be identified. సో ఎలాగ మనకి హబ్ అయితే ఎలా ఉంటుంది, కంట్రోల్ బ్లాక్ అయితే ఎలా ఉంటుంది, అడ్మినిస్ట్రేటివ్ టైప్స్ అయితే ఎలా డివైడ్ చేస్తాము, అడ్రసెస్ కి ఎలాగ డివైడ్ చేస్తాము, క్లాస్ డి, క్లాస్ ఏ, క్లాస్ బి అడ్రసెస్ ఎలా అడ్రసెస్ రేంజెస్ ఉంటాయి, హౌ దే విల్ బి గెట్ డివైడెడ్. సో ఎక్కడ మనకి ఈ ఐపీ మల్టీకాస్ట్ కమ్యూనికేషన్ అనేది, మల్టీకాస్ట్ సాకెట్ అనేది ఏం చూసుకుంటుంది అని అంటే, IPv4 IPv6 మీద అయితే ప్రోటోకాల్స్ చదువుకున్నారో వాటిలో జరిగే ప్రొసీజరే మనకి ఇక్కడ ఐపీ మల్టీకాస్ట్ సాకెట్ చేసే వర్కింగ్ అనమాట. ఏం చేస్తుంది అని అంటే, ఇట్స్ గోయింగ్ టు బి కనెక్టింగ్ టు ద ఎక్స్టర్నల్ వరల్డ్ టు both the TCP and UDP level of systems, and it is going to identifying the address range into which address range the system has been falling into, in which address it has to fall into, which type of address it is, whether how it has been varying with the address, so how it has to be get connected to, whether which protocol it has been following by the device, how the device address has to be changed, the data has to be converted into the పర్టికులర్ ప్యాకెట్. ఆ ప్యాకెట్ యొక్క డేటాని ఎలాగా కన్వర్ట్ చేయాలి, అలాగే ఏ అడ్రస్ కి పంపించాలి, అసలు ఏ టైప్ ఆఫ్ అడ్రస్ లోకి అది ఆ డివైస్ ఫాలో అవుతుంది, ల్యాండ్ నుంచి కనెక్ట్ అవుతుందా, వ్యాన్ నుంచి కనెక్ట్ అవుతుందా, వెదర్ ఇట్ ఈస్ బీన్ లోకల్లీ కనెక్టెడ్ ఆర్ వెదర్ ఇట్స్ బీన్ కనెక్టెడ్ టు ద ఫుట్టి ఆర్ టెల్నెట్ ద్వారా కనెక్ట్ అవుతున్నామా, హౌ ఇట్ ఈస్ బీన్ కనెక్టెడ్ విత్ ఆల్ దీస్ థింగ్స్ ఆర్ బీన్ ఐడెంటిఫైడ్ బై ద మల్టీకాస్ట్ గ్రూప్ అనమాట. ఓకే, అవి లోకల్ సాకెట్సా లేకపోతే నాన్ లోకల్ సాకెట్సా, పోర్ట్ మ్యాపర్ కావాలా అవసరం లేదా, సాకెట్ నుంచి కనెక్ట్ చేయాలా, మ్యాపింగ్ ఎప్పుడు కుదురుతుంది, కనెక్టివిటీ ఇస్ బీన్ పాసిబుల్ ఆర్ నాట్, వెదర్ దే ఫాల్ ఇన్ టు ద IPv4 మ్యాపింగ్ ఆర్ ద IPv3 మ్యాపింగ్ అనేది మనకి తెలుస్తుంది. సో దట్ ఈస్ వాట్ ద ఇంప్లిమెంటేషన్ ఆఫ్ దిస్ థింగ్ విల్ బి డన్ బై దిస్ ఐపీ మల్టీకాస్టింగ్. అయితే ఈ ఫెయిలియర్ మోడల్ మల్టీకాస్ట్ డేటాగ్రామ్స్ యూడిపిలో అయితే కనుక ద ఐపీ మల్టీకాస్ట్ విల్ హ్యావ్ సర్టైన్ ప్రాబ్లమ్స్. ఏంటి అని అంటే, అక్కడ మనకి వాట్ ఇస్ కాల్డ్ యాజ్ టూ-వే కమ్యూనికేషన్, యూడిపిలో మనకి టూ-వే కమ్యూనికేషన్ ఉండదు కాబట్టి యూ మే కెనాట్ సే దట్ there will be proper reliable multicasting, because we will not be acknowledged with any response ఉండదు కాబట్టి we may not rely on that particular multicast communication in the యూడిపి ఇంప్లిమెంటేషన్ లో అయితే మనం రిలయబుల్ మల్టీకాస్ట్ జరుగుతుంది అనేది మనం చెప్పలేము. ఓకేనండి, ఎందుకు అంటే అక్కడ మనకి ఎక్నాలజ్మెంట్ ఉండదు కాబట్టి. అలాగే ఐపీ మల్టీకాస్ట్ మనం గనక జావాతో యూజ్ చేసుకుంటే యూ కెన్ యూజ్ ద multicast socket which is going to have a datagram socket with additional capability to join the multicast groups. Okay, so that is how the constructors will be followed in the UDP using the Java API. Java API తో IP multicasting మనము ఇంప్లిమెంట్ చేయొచ్చు. ఓకేనండి, సో మల్టీకాస్ట్ అడ్రస్సింగ్ మనకి కావాలి, యూ హ్యావ్ టు జాయిన్ దట్ గ్రూప్ అండ్ హ్యావ్ టు ఫాల్ ఇన్ టు దట్ పర్టికులర్ అడ్రస్ so that you will be able to connect it with that particular socket class, and you will be having the identification with that particular socket class. ఆ మల్టీకాస్ట్ సాకెట్ అనే కనుక క్లాస్ కనుక మనం ఇంపోర్ట్ చేసుకుని ఆ పర్టికులర్ అడ్రస్ లోకి మనం ఫాలో అయ్యేలాగా ఆ గ్రూప్ లోకి మనం జాయిన్ అయితే వీళ్ళు ఏబుల్ టు కమ్యూనికేట్. ఆటోమేటిక్ గా మన డిస్ట్రిబ్యూటెడ్ ఎన్వైరన్మెంట్ లో యాజ్ అ వన్ పార్ట్ ఆఫ్ ద ప్రాసెస్ అవుతాము. అందులో మనం కమ్యూనికేట్ చేసుకోవడానికి వి ప్లే ద రోల్ అండ్ విల్ బి ఏబుల్ టు గెట్ దట్ పర్టికులర్ కమ్యూనికేషన్ సింక్ అనమాట. కమ్యూనికేషన్ సింక్ మనం రిసీవ్ చేసుకోవడానికి we are having the ability. Okay, so that is how the multicasting and the IP multicasting will be implemented both in the Java and also at the UDP and the what is called as TCP level, and these are all the different characteristics which are able to provide the possibility to build up our distributed environment with the multicasting probability. So multicasting వల్లే మనకి distributed environment ని distribute చేసుకునే ఛాన్స్ వచ్చింది. ఓకే, here ends our fifth unit. ఇక్కడ మనకి fifth unit complete అయింది. So what we been explained in this fifth unit is how we are going to getting the resource sharing of the files that are being remotely mounted on the different clients. So రిమోట్ ఫైల్ సిస్టమ్ ఎక్కడో మనకి డిఫరెంట్ డేటాని మనము మౌంట్ చేసుకుని ఉంటే వాటిని మనం ఎలా యాక్సెస్ చేసుకుంటాము, how the distributed file system will be called as, what are all the different storage models we are having, how the evolution has been done, what are all the distributed different storage solutions, what is the distributed file system, how it is going to be working with, what are all the functional and non-functional requirements, what are all the file system modules, okay, what are all the file attribute records when they are being stored with, what are all the different file storage system examples, okay, and requirements of it, how the transparency will be exhibited, and also what is the file service architecture in general, okay, how it is being accessing with the three service modules, and what is the file service architecture model, and directory service network file system, how it is helpful for us in order to connect with the remote file systems, and also how you are going to mounting the data onto the remote file system, and also network file system architecture, sun network file system, okay, what are all the Unix operations that will be used in the network file system and the file system operations, network file system operation and its overview, caching in the network file system, okay. Next one is mounting of the data, accessing the data, and implementing the NFS, right? Next, P2P systems. How this particular P2P system is different with the client server model of the file system accessing. How it is being different with what are its characteristics, advantages and disadvantages when compared to the client server. Applications of the P2P system. Features of the P2P system include P2P middleware and the routing overlays. What is the NAPT system and how its legacy is being followed with the present system, present what is network file systems and its architecture, its limitations. Okay, peer-to-peer middleware functional and non-functional requirements. What is the routing overlay? How it is being helpful along with the IP packet routing? Okay, and what is the coordination and agreement? What is the purpose of the mutual exclusion in it? And how the mutual exclusion algorithms will be implemented in order to achieve the consistency in the distributed file sharing or the distributed environment, and how the election algorithm will be used in order to elect one of the system to be act as a role player, and how the corresponding algorithms will be useful implemented in the election process, and finally, what is a multicasting process? How it will be usable for building up the distributed environment? How this particular multicasting will be used to implement and develop the IP multicast, and how it will be useful in the communication process. Okay, so this is the fifth unit that we discussed. We'll be going to discuss about the transactions and the transaction procedures in the sixth unit. That is how the data transactions will be considered, how they will be maintained with the concurrency, data recovery, and all those things will be seen in the sixth unit. So I'll be stopping here. Get ready for the next class. Stay safe. Okay. We'll be continuing with the sixth unit in the next class.